So I would say if someone who is looking to become a researcher, I guess mathematics is fundamental. I mean, you can argue that in this field, in the era of AI, you don't need anything. I would sort of disagree to that because yes, AI makes your job much easier. Like my job every day is getting much easier and it accelerates very fast. A lot of my productivity has been improving so fast. But then still you need to know the fundamentals.
Hey everyone, welcome back to another episode of Anyreach Roundtable, where we explore how AI is transforming the way we work. I'm your host, Richard Lin, CEO of Anyreach, and today's guest is Shangeth, a senior machine learning scientist at Anyreach for our Meet the Team series. Shangeth, it's great to have you here.
Hey Richard, how's it going?
It's great. Well, thanks for jumping on. And just so for our audience, do you mind sharing a little bit about your experience, your background, just so they can get to know you better?
Yeah, sure. So my background is from machine learning research. I've been doing machine learning research specifically in the field of speech AI for the past 6 years since my college days. I've been working with end-to-end voice AI stack for a very long time now. I've almost worked in almost all the components of this end-to-end stack AI, even till the multimodal LLMs as well. So yeah, that's kind of my background there.
Got it. Well, thanks for sharing that. So as a senior machine learning scientist at Anyreach, what kind of sparked your journey into getting into AI, and where did it all begin for you?
Into AI, right? During my background is actually mathematics and electrical engineering. I came to understand that probably I'm not interested in the electrical and electronic aspects of it. I was interested in the signal processing aspect, so I knew I had to figure out what I had to do. So I started exploring different things, networking, into software development, web development, a lot of things. So I got into AI through a lot of internships actually. So since my first year of college, I started doing a lot of software development internships, network managements, and things like that. During those days, one of the project that I had was computer vision project. It wasn't really a computer vision project. The reason I picked that was I wanted to explore more into network managements and server client systems and things like that. So I picked a topic. What I thought was I will quickly, whatever is the state-of-the-art computer vision model, I'll just quickly use that. But I will explore more into the, networking aspects of it. But what happened was, as I explored more into that, I got into computer vision, and I really liked it. I started reading a lot of research papers on it. So the project turned out to be I just used something from the networking side of things and explored a lot more in computer vision side of things. And that's how I got into AI first, to say. That was the time of ImageNet competitions and things like that. So there were CNN, Celestiums, and those kind of models. So after that, with that experience, and I started reading a lot of machine learning research papers during that time. I wanted to work on machine learning research. I figured out, kind of like that. So I sort of went to a lot of professors and started working with them. My first research project was actually in stock prediction. So the paper title was Neural Arithmetic Logic Units for stock predictions, and that gave very good results. I sort of worked 6 months on that topic, and from there I got interested into learning about representations of how you represent different kind of data and things like that. So then I started working on representation learning for different modalities, image, videos, speech, and of course text as well. Then I also started working with Professor Isabel Cohen of Indria Paris. I spent 2 years working with them on various aspects of multimodality and automatic deep learning as well. That's where I got too deep into research, and I kind of came to know that speech seems to be interesting to me, because speech is not just if you take some text paragraph, right? It has some semantic meaning to it, and it has few more information to it. Speech has all the information that you have in text, but also the speaker information, content information, prosthetic information, and environment information, and so on. So I wanted to explore all the aspects of these things. It was a bit complex, so I liked the challenge at that time. Right now, speech is not so complex because there are so many open source models that you can use. But at that time, you didn't have any model. Speech was not really that famous at that time. So yeah, that's how I got into that. Then I spent sort of 1 year at NTU Singapore as a research assistant, exploring various aspects of speech perceptions, emotion, uh, speaker, age, height, gender prediction, a lot of things, language aspects. Then I spent 3 years at Skate AI as a machine learning researcher. There I spent my time end to end from all the stacks in end to end voice bot systems from ASR, LLM, TTS, improving those things. This was actually pre-LLM era. We didn't have LLM at that time. I mean, language models were there, but not really the large language models that we have right now. So yeah, from there, I also worked a lot with turn-taking aspects of things as well. Then came the LLM era, and a lot of things actually changed. It was quite interesting, challenging, and complicating as well. So then I got also into multimodal LLMs during that time. I mean, LLMs were a thing, but since I was always into speech and comparing speech and text, I got into multimodal LLM as well, and yeah, that's kind of my background.
Got it. Well, yeah, thanks for sharing that. I mean, I think it's pretty interesting that you went from research and vision, and then obviously text, and then now into speech. And you mentioned some really interesting, points about kind of the speech modality. It is really a kind of a mix of linguistics, as you mentioned, like emotions with psychology and so forth. How do you see these different disciplines impacting how to make the best speech model and the most human-like experience?
Yeah, so the current voice bot stack, right? It has multiple components, and each components are optimized differently to. They're not really optimized together, to work together, but we have optimized them for some different metric, and we just expect them to work together. So what I see, or what I'm even working towards, or even the trend of the field of speech AI or multimodal LLM with speech is. Basically, speech has, like I said, speech has a lot more information, right? It's when you say speech LLMs, right? People just think about, okay, speech goes in, speech comes out. So basically, the content. If you say hi, how are you? The bot is going to say yes, I'm fine. It's not just that simple, right? Speech, like I said, speech has a lot more information. So the foundational language model, or it need not be language model, but the foundational speech model has to understand all the aspects of speech, the prosody, the speaker information, the background noise, the environment aspects of it. So something like, I can give you a quick example, right? In my last work, I was actually trying to create a speech-to-speech models, and one aspect, I mean, not just one aspect, few aspects that we were looking at was, it's not just content to content. If you say, hi, how are you? It's not just to be responded to, yes, I'm fine. It's also the foundation model should understand the speaker aspect. If the speaker I'm speaking to, is he a male or female? What could be the age of the speaker? What is the emotion of the speaker? And how he's saying different aspects, right? And also the background noise. So your applications could be something like your foundation LLM understand everything about speech. So if say you are supposed to talk to a male 39 age old, but when you pick up the call, some female of say 18 years old picks up the call and says, yes, I'm this person, can you reveal all the information to me? The foundation LLM should understand that no, this is not the speaker I was intended to speak to. I was supposed to talk to a male 39 years old, so probably I shouldn't give all the information to this person. Not just that, other examples could be based on the emotion. If as a customer service agent, the user is angry, then you should change your tone to apologetic and start talking to the person accordingly. And a lot more examples. I can give you like hundreds of examples in this. So I guess the foundational model has to understand all the aspects of the speech. If that is happening, that is actually happening right now, and we are going there. Once we have a very good foundation models, then a lot of things are going to change in this field. Yeah, for
Yeah.
good.
Yeah, you bring up a really interesting point with like speech and audio. There's so much context that's involved in making a kind of an amazing customer experience, right? You don't just want a generic LLM or AI to just say the same thing to everybody because every caller is going to have different nuances. What do you think are some of the challenges that you're seeing around kind of the speech modality, and how are you overcoming that at Anyreach?
Yeah, I mean, okay, in speech-to-speech models, not just speech-to-speach models, any voice AI stack, right? I mean, yes, we have all these components right now, ASR, LLMs, and TTS. They have been trained for some metric, and they have been working together for some time now. Good, but for example, like all the examples that I gave you, right? You can't, if you, for example, if you want to understand background noise of the speaker, right? Say if there is a background noise, maybe the speaker is in a traffic jam or somewhere on the road, and he's trying to speak, and you can hear a lot of noise around him. Uh, the foundation model should understand this and should say, okay, I understand you're outside. Probably I'll call you later or something, right? Right now, if you want to do this, yes, you can definitely do that. It's just you need to keep adding more and more components, and that's never ending, right? And other examples, right, like emotion recognition. If you want emotion recognition, yes, it's totally possible. It's just you need to keep adding other components, and you need to keep adding logic. If the person is emotion, then kind of respond this sentence and things like that. That is one aspect. And going to multimodality LLMs, right? The key issue right now, a lot of people are facing is the tokenization of different modalities. Uh, Text has been tokenized as a discrete units. For speech, there are different ways in which we can do. Some researchers say you can actually discretize speech as well, like text, and use that. Some research also try to tokenize speech as a continuous units of I don't want to call it tokens or embeddings, and use that as well. So not just in speech, it's about multimodality. In any multimodal setting, it's about tokenization, and I think the next coolest paper will be on tokenization, and that should probably help us a lot in a lot of things related to speech to speech.
So just for our audience, because you brought up two interesting, more technical topics of like tokenization and embeddings. Most of our folks that are tuning in are not super technical, so can you maybe describe what those two concepts mean?
Yeah, sure. So when you are chatting with LLM, right, the ChatGPT, the text input that you're sending, it's the LLMs understand text as embeddings. So all the text, hi, how are you, that you're sending to ChatGPT, it's been converted into discrete units. Hi is a discrete unit, and that discrete unit, it's been embedded into the embedding space using an embedding matrix, basically. So anything that you're talking to the LLM is being translated from whatever is the text into embedding space. Embedding is basically vectors that can represent the information that you're sending. Similarly, when you send an image to ChatGPT, the image is being converted into a form that LLMs can understand, basically embeddings. So this translation of text into embeddings or image and audio into embeddings is tokenization. So that's where the research
Got
is
it.
going.
So yeah, I mean, it sounds like, natural human language, right, is being transformed into machine readable language, right?
Yeah.
More specifically for kind of AI LLM models. Super interesting concept. And, as you kind of think about how AI is deployed, especially around speech and voice, what are some ethical considerations that you see currently, and challenges around that? And then how do you think that's going to evolve over time?
Yeah, I mean, you can see hundreds of examples on social media about ethical challenges on whatever we are doing.
Yeah.
I'm not too much into responsible and ethics in AI, but as a user, you can see like hundreds of examples of how things are changing. Even at Anyreach, we are doing a lot of research on how we can sort of adapt an agent's behavior. I mean, from this perspective, it looks like, yeah, I want to adapt that agent's behavior because the client may want to replicate their own agent and so on. But if you can use the same technology for whatever literally you want, I can quickly make a bot and I can make it to speak like Richard Lin, and I can sort of do anything with it, right? For one example could be just voice cloning, right? I can just clone your voice. I can do whatever I want with it. I can call your relatives or people that you know in your networks, and yeah, I can sort of kind of scam you as well. So
Right.
I mean, yeah, as time goes, I'm sure there will be some other way to avoid this as well. People are already working on how to, detect AI generated text and even speech as well, even images and videos as well. So yeah, I mean, there will be few challenges as time goes and these models keep evolving, but from the red teaming side of thing, we will also keep coming up with different methods of identifying, yes, this is an AI generated voice, so probably you shouldn't believe that. Probably you will see future in WhatsApp, you will have a feature calling this speaker kind of sounds like this is an AI generated voice, so probably you should be careful or something like that. Yeah.
Yeah, you bring up a good point. I mean, AI is kind of like a double-edged sword.
Yeah.
It has all these different benefits that can be provided, but in the wrong hands, it can also be super detrimental, right? Like you clone someone's voice or you clone someone's image, like we've seen this with deepfakes, where in different industries that are not kosher for this conversation, where celebrities are being cloned, their voice, their image, and so forth, and being used in a very irresponsible, unethical manner. So, and you kind of brought up the concept of a red team, and I think as enterprises adopt more agentic AI into their business operations, that there's going to be a whole suite of new skill sets, new kind of hires around how do we make sure that our AI is safe and ethical, which means we're going to have a red team. We're going to have hackers that break our system and try to find those edge cases, right? So, as you kind of think about agentic AI, multimodality, one of the key challenges that we've seen with our clients is you can get a great demo out the door, maybe even push it to production, but then maintaining this agent over time and making sure it's doing the job or even doing it better than where it started is obviously a key area of concern, and it's also a huge operational headache, right? And so as you look at kind of the current trends, how do you see unsupervised learning techniques really kind of shaping what we're doing here at Anyreach?
Yeah, I mean, unsupervised learning has been there for a very long time. Earlier, it was just k-means neighbor. Then every language model that has been trained is sort of unsupervised learning only. It started with sort of smaller models like BERT. I would call it self-supervised as well. But then, we have abundance of data. Even at Anyreach, we can get like so much of data. But how we exactly use that to improve our systems is what even at Anyreach we are trying to work, right? For example, if say based on a customer client called interaction, human-human interaction, we can replicate the agent, right? We are essentially doing that in an unsupervised way. We don't have tagging of data of okay, this was the first turn, this was the last turn, and so on. Sort of unsupervised and self-supervised. We are tagging the data from the data itself, and that's how we are doing. The major challenge here, again, in building the system could be major challenge I can see is first is the evaluation, right? Even every company is definitely struggled with evaluation. Unless you have abundance of human resource where you can use them to evaluate each and every aspects of the agents that you have, the voice aspects, the response generation aspects, turn taking aspects. And talking about turn taking aspects, building an agent, right? The major difference between a human agent and the voice agent, voice virtual agent that we are generating will be the turn taking aspects of it. You can optimize all your components, your ASR, LLM, TTS, to be as perfect as possible, and still the bot would sound like a robot because of this turn taking behavior. Most of the systems right now, building voice agents, they have sort of a fixed, time-based systems. So if the user didn't respond for say 4 seconds or 3 seconds, then the agent has to start generating, the LLM has to start generating their response and thing. That is not going to work for long term. And even at Anyreach, we are trying to spend a lot of time in this turn taking aspects. So when should an agent start speaking? When should an agent start listening? When should an agent interrupt the user and things like that? So that's evaluation, and this turn taking aspects is the major challenge that I'm looking at. And coming to unsupervised learning, we are actually trying to use the human behavior data of human interactions to sort of model this turn-taking behavior as well. Sort of when should the user or the agent, start to speak, end their utterance? When should they interrupt? When should they back channel and things like that? So it has a lot of potential since we have abundance of data, and the tagging is very less. So unsupervised learning.
Yeah. No, it's really interesting. I mean, I think voice is such an uncharted territory. You brought up the topic of evals being a crucial part. It's not just tagging information, but really, getting the human in loop feedback of the conversational UX, right? And I'd say the space is kind of akin to autonomous driving, where you think about the Waymos and the Teslas of the world, what you see today on the road. And actually Tesla just launched their robo-taxi, I think 2 days ago. First car that's like fully autonomous that can pick people up like an Uber. But what we see today wasn't what it was 10 years ago. Like Waymo literally had a human sitting behind the wheel for like 5 years and managed that drive for a long time, gathered the data, and then they sent it to Scale AI. And Scale had a whole bunch of humans from the Philippines, Mexico, and so forth that would look at all this data and eval and say, okay, how do we get this data back into the model to improve the capabilities there. You brought up another really interesting point about turn taking, interruption handling, even back channeling, right? The idea of how do you make the agent say pause, and so forth. Those little like human nuances that usually are in a conversation. And funny story on my side is like I've went to several conferences, talked to a lot of these really large enterprises saying they do AI voice, and their turn taking is just terrible, right? And as you mentioned, some companies is pretty unsophisticated, where it's like, we're just gonna hard code 3 seconds as the time period, or they don't even have it at all, right? And
a lot of the state-of-the-art system right now uses these fixed timings.
Right.
If the user is not responding for like 2 seconds, then the agent should start speaking.
Yeah. Like funny enough, I was actually on a call yesterday with one of our competitors, and the C-level was like, oh yeah, we do all the AI voice, it's freaking amazing, our models, we built everything proprietary. So I said, okay, well, do you have a number you can call right now, live on the Zoom call? Like, let's hear it, all right? And so he tries to find it, and ends up finally getting the number, and the interruption handling just didn't work very well. The agent just stopped talking after a while. And then I was mentioning at the conference with another competitor, they also said the same thing. Oh, our AI is amazing. I said, okay, great. Let's call it. Had no interruption handling, right? And I did a little fun exercise where I said, hey, can you put your AI agent on a speakerphone? And I'm going to put ours on a speakerphone and let them talk. Okay. And it was a night and day difference, right? So that's absolutely crucial. And like the research that we're doing here, especially under your lead around how do you actually do the turn taking so it's a fluid conversation, it is very hard to crack, right?
Yeah.
Yeah.
So there are several aspects, right? First is perception of turn taking, right? Like we have to understand what the speaker is talking about and when he's talking about something, and based on that, we should have an intelligence system that should take in all the intermediary speech signals and try to understand, okay, the speaker's pitch is sort of falling, so probably he's going to stop at this point. So probably I should, as a human, you do the same thing, right? When you're talking and when you're about to end, I know you're going to end based on 2 things, the acoustics and the semantics. The words that you use can mean that you're about to end the sentence. And the perception of your acoustics, based on that as well, I can understand that you're going to end your sentence. So based on that, I'll start formulating my thoughts, right? Okay, he is going to end his speech here, so probably I should start thinking about what to respond next. So that's what essentially we started as a fundamental. We should first understand when the speaker is going to stop, both acoustics and semantics. We are trying to use both the aspects to sort of, if we have a dedicated LLM for that, that can understand that you're going to stop talking, and based on that we will, our main LLM will start generating our text for the next response of the agent. And then coming to the aspects of adaptation, right? The turn taking is not same for different languages. For English, the turn taking behavior could be different, and for French, it's completely different. I came to know this since I started working with the client's data, and yeah, in French, the turn taking is very rapid, and you could expect the same thing for different languages as well. So we can't keep doing this, right? If we build a turn taking model for one language, I can't extrapolate that for all the other languages that are possible.
Right.
So I have to learn from the data that has been given to me, and that's what we are trying to do. We are trying to adapt the turn-taking behavior of the agent-human interaction from the client's call, and based on that, we are changing the aspects of turn-taking in our systems as well. So yeah, that's the idea, and that's the future that we are looking at. We have a stable system that is doing a very good turn-taking, and we are also trying to extrapolate to other languages as well.
Yeah, I mean, you brought up a good point about multilingual capabilities. I mean, a lot of enterprises, especially when they're global, are going to require, different language support. And, there's cultural nuances, like what you can say, what you can't, right? And as you mentioned, like the flow of the conversation and turn taking. I was at a event recently with one of our investors, and he's Japanese. Yohei of Untapped Capital, and we were talking about voice agents and voice experiences from a human perspective. And he was saying that for the Japanese culture in a business deal, if you're talking to an executive, they usually pause for about 20 to 30 seconds to think about their response. But if you interject before they had time to think in that 20 to 30 second time frame, you actually don't get the real information that they are actually thinking about. So it brings up a really interesting nuance, because if I'm an American trying to close a Japanese deal, and Western cultures, like, we don't like awkward silence. We like to put in fillers when there's no one talking, but if we did that, then the deal's dead, because you don't actually know what that executive is thinking, right? So all those nuances in different languages, different cultures, different people, it's definitely a key challenge. And I think a lot of folks that are thinking about AI voice, especially for the enterprise businesses, they're not thinking at that level of nuance, right?
Yeah, so even most of the proprietary models that we are testing, both language models and speech, and also open source models as well, they don't really consider these nuances. Yes, they have some data and they have been trained on those data, but it doesn't reflect when you infer those models. Yes, those models are good for English speech, but when it's a multilingual model, but if you try to use it for French, the turn-taking behavior is very bad. Even the vocabulary understanding of those models are very bad. So it is actually essential to adapt from a lot of aspects of the human-human conversations for different languages, different cultures, and essentially that's what we are trying to do at research team in Anyreach, right? We are trying to understand the vocabulary of what the human-human conversation is about, the turn-taking aspects of it, like how you should pronounce different words or different vocabularies based on the context, and the customer service agent's behavior itself is going to change, like based on the locations and things like that. So,
Right. Yeah, no, it's funny because we were just testing out the Mandarin speaking bot for a potential prospect, and the out-of-box foundational models, especially the ones based in the US, are terrible. What I like to call their buns. But I was testing it, and then the agent was jumping in and say, 好的, all the time. And it's like, that's good, right? And it was like super unnatural, where, my girlfriend and myself were both Chinese. We were just laughing at, like, when it's Chinese, it's like a psychopath, right? With the English models. But obviously, we're seeing like even additional open source models coming out of China, DeepSeek, and there's stuff coming out of Alibaba and Tencent that just perform better, right? So there's a lot of kind of nuance in which model providers you use across the stack for which use case for which language, which obviously adds a ton of complexity. And so as you kind of think about how kind of the AI industry and the research and so forth are advancing, what skills should aspiring MLEs or machine learning engineers or researchers focus on developing?
Okay, I mean, a lot of things has changed since I started, right? During college, if I had to read a research paper and implement it, it was a project for me itself, like just reading a research paper, trying to understand what it means. And to understand that research paper, I had to refer like 10 other research papers because it's based on that and citation has been given. So things have changed a lot. I can read like hundreds of papers in few hours with the advancing AI. I can sort of, if I want to if I have a research paper, I want to quickly understand, I can do that quickly. If I have a research paper and I want to implement it in, say, Python code or even MATLAB code, if anyone uses MATLAB anyway, if I want to do that, I can quickly do that. Of course, I'm not going to say AI is going to do 100% of your job, but sort of, I would say 70 to 80% of your job is done there. And of course, you need some expertise in the field, and you have to guide the AI to do your job there. So I would say if someone who is looking to become a researcher, I guess mathematics is fundamental. I mean, you can argue that in this field, in the era of AI, you don't need anything. I would sort of disagree to that because yes, AI makes your job much easier. Like my job every day is getting much easier, and it accelerates very fast. A lot of my productivity has been improving so fast. But then still you need to know the fundamentals. I know the fundamental is going to change. As probably 10 years down the line, probably you don't need to know statistics, or I could be wrong. That's going to change, but at this point you should definitely understand all the fundamentals of all the mathematical aspects of machine learning. To be a machine learning researcher, right, a lot of people think you need to know all the sciencey stuffs. You need to know a bit, but it's more of creating the hypothesis for your experiments and have some creativity of okay, I read this research paper, they did this. I read another research paper, they did this. Probably if I combine both of those, maybe some results will be there. It's not about just writing a research paper, it's about coming up with a solution for a problem that you have. So that creativity, that thinking skill is what you probably need. You can learn all the other stuff, all the mathematics and other stuff. In this era where it's very easy to learn. So that's what. And of course, if you're someone in this field, right, start using AI tools. It's going to help you a lot. It's going to make your job much easier in every aspects. And one thing I noticed is earlier when I was working with in a company on the team, right, there will be engineers, there will be researchers, and there will be PMs. While working with them, you don't have all the skills of a software engineer. So say if I did my experiments and I want to deploy the model, I depend on the software engineer to, I can do some job, like 10 to 20% of their job and give it to them. Right now at this speed, right now I'm doing like 60 to 70% of the job that the software engineer has to do in deploying the model, and the rest of the 30 to 40% is the skill of the software engineer that I don't possess. Probably I can acquire that as well. Same for software engineers as well. They also now understand what a researcher is doing and can do like 20 to 30% of job of the researcher. So there is always this merging of roles between us. So I guess in future, for a researcher, if I want to talk about, you just to be ready to learn stuffs here and there. Be a project manager, product manager, be a software engineer as well. Not 100%, maybe not now. Maybe in the future it could be 100% as well. But at this time there could be some intersection between roles, and you should be ready to acquire that.
Yeah. I think this whole merging of job responsibilities, especially in tech, we're starting to see that convergence, right? Where traditionally at like FANG, the Facebook, Amazons, and so forth, the trifecta is like product managers, the software engineers, and then you have your designers. But even in that area, like a lot of those roles are starting to merge, right? Where PMs are coding some prototypes up, right? They're doing designs on the fly because of a lot of the AI native tooling. And you kind of mentioned like adopting AI is kind of like the future of MLEs and so forth and researchers. What tools do you use maybe on a daily basis? And then where do you see kind of speech as a modality kind of evolving in the next 3 to 5 years?
Okay, for tools, I actually use a lot of tools. A lot of tools in my both phone and in my MacBook has been changed. I stopped using Google for good. I don't use
That's what I'm hearing.
Go
People
anymore.
don't
Yeah.
people don't Google search anymore. Yeah.
I mean, Google gives you the websites, yes, good. I mean, right now Gemini is also trying out something, but then,
Yeah.
yeah, I have a question. I just quickly want the answer to it and citation to that as well, so I can verify, yes, that answer is fine. That's all I want. Google wasn't doing that. Maybe in the future they will also be doing that. So yeah. Yeah, I've been using, of course, like everyone, Claude, ChatGPT a lot for research, a lot of research, to read research papers, to find out research papers. I use Claude and ChatGPT a lot. These LLMs with the advantage of tool integrations, right, has been blessing for all of us. They can search very well, do deep research very well, and does most of my jobs. In searching, a lot of searching job for me is done right now. Yeah, then coming to implementation of these things, yeah, there's a phase of ideation, hypothesis, and how do I, take that hypothesis into an idea and replicate that. Once I have that idea of what I have to implement, then I can come up with the coding side of things, right? Even there, tools like Cursor or Codex are helping a lot. I use Cursor to, from ideation to code. I don't rely 100% on Cursor. I mean, the accuracy is improving, but I really don't rely 100%. Sometimes it's confusing, but then the accuracy is still improving. It's been improving a lot recently. And then once some experiment is set up, the code is done. Of course, I will also have to put my input there as well in setting up the code base, in setting up the training experiments. Once the experiment is done, I also use Codex recently to sort of refactor the code to sort of understand what this code means. Can you refactor it better? What issues do you see in this code and things like that? So yeah, I mean, there will be hundreds of other apps, applications as well. But yeah, I'm sticking to a limited set of applications. I've been using that.
Yeah, it
Yeah,
makes a lot
then
of
coming
sense.
to
Yeah.
speech-to-speech or multimodality LLMs future, right? I guess once the foundation model is there, foundation model for the current LLMs where, for example, GPT 3.5 or GPT 4.0, those foundation models were good, so people were able to build a lot of things on top of them. So right now in speech-to-speech, you can't really, find one foundation model that understands all the aspects of speech. And once that is done, and even at Anyreach, we are trying to do that as well. We are trying to explore this side of things as well. Once that is done, just like ChatGPT, how you're trying to do things with ChatGPT, you could use those speech foundation models for various applications related to speech. It could be an end-to-end voice bot stack, or it could be as simple as an emotion recognition, or a lot of things. Creativity is the limit there. Yeah.
Got it. Well, awesome. Well, I appreciate you, Shangeth, jumping on Anyreach Roundtable. I think the audience learned quite a bit, especially on the technical aspects. Don't worry for the audience if there's any terms here that kind of flew over your head. We'll have a little glossary in our description explaining what those mean, so you can backtrack on our episode today and get a better kind of context and insight into Shangeth's expertise on the speech field. So Shangeth, pleasure to have you on. It was great, and I'm sure our audience would really appreciate kind of learning more about how multimodality speech systems will continue to evolve in the coming future. So thanks again for jumping on.
Thanks a lot, Richard.
Absolutely. Thanks, Shangeth. Bye-bye.
Bye-bye.